Hello. In this video, we want to look at the constant multiple rule and sum difference rule. So basically, the constant multiple rule, it just means that if there's a constant in front of a function, that constant can go out front if you want it to. Now, what's great about this is that you can basically ignore the constant and just put it with everything else. Now, there is the sum difference rule. That means that the integral of a sum difference dx is equal to the integral of the sum or difference of each of the integrals. Now what this means is that the integral or the integration is what we call a linear operator. It will distribute using sums. Also, that constant can go out front. Now note that because of this, this does not mean that something like this, the integral of x times the square root of x minus 1 dx, is not the same thing. I can't bring this x out front, making that x integral of the square root of x minus 1 dx. I'll be honest with you, if it did work that way, integrals would be a lot easier. But they don't, so we can't do it that way. Okay, so let's look at this. I want to use the rules to do the integral of 2v cubed dv. So to do this, first of all, I can bring the 2 out front. I'm going to go through this kind of quickly, or I'm going to go through this slowly, and I'm going to show you the quick way of doing it. So bring the 2 out front. So we're really looking at the integral of v cubed dv. So to figure this out, we just use the power rule. So 2 right there, and then what's the integral of v cubed? Well, we add 1 to the exponent, and then multiply or divide by 4. Multiply by the reciprocal or divide by the exponent. And then plus c, and technically what we have is distribution here, right? Now notice that I can distribute the 2, and this is going to make this, what's 2 divided by 4? Well, 2 divided by 4 is a half, v to the 4th power, and then technically plus 2c. That's technically correct. I'm going to make this a c1 though, for now. And the reason why is because 2 times a constant is just some other constant, isn't it? So this would become 1/2 v to the 4th power plus some new constant. It really doesn't matter what the constant is. This is some arbitrary constant. So 2 times a constant is just a new constant. That's all. But we don't really like even doing that distribution because it doesn't matter. So really, this is what you would think of this as. And I really should put that 2 a lot closer. And there we go. Good, and that is in fact the answer. Now I'm going to go ahead and show you a slightly quicker way of doing this. So if we have the integral of 2v cubed dv, don't worry about bringing the 2 out front, just rewrite it. 2, and then v to the, well, 3 plus 1 is 4, and then out to the front, write down 1/4 times that, plus c. Because that's the reciprocal of 4. 1/4 times 2 is a half, v to the 4th power, plus c. And there's your answer. By the way, once you get really used to these, and you will, I promise, you actually can go from here to here. Just ask yourself, v to the 4th power first, the reciprocal is 1/4, 1/4 times this number out front is a half. Now notice that if I take the derivative of this to get back to the original, or to the original integrand, 4 down in front, 4 times a half is 2. That's the right coefficient. Subtract 1, 3. Good. And the derivative of any constant is 0. So that's why that has to be there for the integrand, or for the integration constant. But when you take the derivative, it goes away. Good deal. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.